Hello children, warmly welcome to Guru Gedara educational program. As usual, today also I am going to teach you another important lesson in grade 11 science syllabus. In previous programs, we studied about electronic components, p-n junction, depletion layer. After that, in the second program, you studied about rectification, full wave rectification, half wave rectification. Right, my dear children, today I am going to teach you another important lesson which comes under electronics, transistors. Right, let's study about transistors. I think this will be an interesting lesson for you. Right. First of all, I would like to ask you a question. Do you know what is called as a transistor? This picture shows you some examples for transistors you might have seen. Right. Actually, what is called as a transistor? Transistor is an electronic device that contains two p-n junctions. I am sure you can remember what are p-n junctions. A p-n junction is made by reverting p portion with n portion in a special manner. Right. When you think about transistors, my dear children, there are two types of transistors. What are they? As shown in the slide, you can see Pnp transistors and Npn transistors. What are they? Pnp transistors and Npn transistors. Let's study how to make a Pnp transistor. Do you know? As you can see, Pnp transistor is made by placing a small n portion between two p portions. Among the two p portions, the highly doped p portion is called as emitter. You can remember p-type semiconductors and n-type semiconductors are made by doping. So, highly doped p portion is called as emitter. The less doped p portion is called as collector. Then the n portion in the center of the Pnp transistor is called as the base. That means you can understand, my dear children, transistor consists of three basic parts. What are they? Emitter, collector and the base. Right. In Pnp transistor, n portion acts as the base. Right. Let's focus our attention on the Npn transistor. As you can see, Npn transistor is made by placing a small p portion between two n portions. Here, among the two n portions, the highly doped n portion is called as emitter. Similarly, the less doped n portion is called as collector. Right. Now, what is the base? Right. You can understand. In Npn transistor, the small p portion at the center is called as base. Right. Now, I am going to show you basic structure of a transistor and how to identify base, collector, emitter, and how does charge carriers flow in the transistors. Right. As you can see, Pnp transistor consists of n portion between two p portions. Npn transistor consists of a p portion in between n portions. Right. When you draw our attention on the Pnp transistor, charge carriers are the holes. Holes act as the charge carriers. You can remember p-type semiconductors consist of larger amount of holes. So, holes act as the charge carriers. Now, what is the direction of current flow in the Pnp transistor? That is from emitter to collector. When we focus our attention on the Npn transistor, electrons act as the charge carriers. Why do I say so? As you can remember, N-type semiconductors are made up of by doping large number of free electrons. That means we doped group 5 arsenic or phosphorus. So, Npn transistors consist of large amount of free electrons. As a result, we can understand free electrons act as the charge carriers in N-type semiconductors. Right. What is the direction of the current flow? In Npn transistors, current flows from collector to emitter. Right. Pnp transistors, current flows from emitter to collector. That's the difference between direction of the current flow in Pnp transistors and Npn transistors. Right. Now, let's focus our attention on the symbol of a transistor. Because we should have a good awareness about the symbols of Npn transistor and Pnp transistor. We have to get ready for the O-level exam. There are questions relevant to the symbol of the transistor. Right. My dear children, as you can see, there is a difference in the Npn transistor and Pnp transistor. Check whether you can identify the difference. Are these symbols same or different? There is a little difference. What's that difference? When you focus our attention on the symbol of Npn transistor, you can see the arrowhead is pointed towards the emitter. But when we draw our attention on Pnp transistor, the arrowhead is pointed away from the emitter. That's the main difference that we can see among the symbols of Npn transistor and Pnp transistor. Right. Let's learn how to identify parts of a transistor using the symbol. What is called as base? In any transistor, base is located at the center. The center portion of any transistor is called as the base. Then what is emitter? How can we identify the emitter in a transistor? Emitter always located near the arrowhead. Once you identify the arrowhead, emitter is located closer to the arrowhead. This is how we identify the emitter in a transistor. Next part is collector. Then, do you know how to identify the collector? Yes, it's very easy. Why do I say so, my dear children? Because once we identify the base and emitter, the remaining terminal is collector. Then arrowhead is there. You can identify an arrowhead here. What is the use of arrowhead? What can we identify by using the arrowhead in a transistor? My dear children, keep in mind, arrowhead indicates the direction of flow of current. What is that? Direction of flow of current is indicated by the arrowhead. Right. Now you can identify what is the base, collector, emitter, and what, if I ask you a question, what kind of transistor is shown in the picture? Is it Npn transistor or Pnp transistor? Now you should be able to find out the type of transistor used in the given diagram. What do you think that? Arrowhead is pointed towards emitter. So this should be a Npn transistor. Npn transistor. Right, my dear children. How to determine that? As I told you, arrowhead points to the direction of emitter. This is how we identify, this is how we determine Npn transistors using the given symbol. Right. If I ask you another question, what is represented by this arrowhead? Arrowhead represents the direction of current. As you can see, current flows from collector to emitter in Npn transistors. Right. I am going to ask you another question. Try to answer. What is shown in this diagram? What kind of transistor is this? Is this Npn transistor or Pnp transistor? You should be able to identify. Try to identify. This is a Pnp transistor. Why do we call for this as a Pnp transistor? How to determine that? You can understand, arrowhead is pointed towards base or away from the emitter. So by using the arrowhead or the direction of the arrowhead, we can find out whether it is Pnp transistor or Npn transistor. Right. And also we can realize that in Pnp transistors, current flows from emitter to collector. All right. Let's study how to bias a transistor. What is called as biasing of a transistor? My dear children, I would like to mention you, though we studied about the Pnp transistor and Npn transistor briefly, in our O-level syllabus, we have to consider only about Npn transistor. So I am going to teach you, we are going to discuss only about Npn transistor. Let's focus our attention how to bias a Npn transistor. When using a transistor in a circuit, appropriate voltages must be provided to the terminals. This is known as bias in a transistor. What is that? Bias in a transistor means when using a transistor in a circuit, appropriate voltages must be provided to the terminals. This is known as bias in a transistor. Right. When we focus our attention on the Npn transistors, the C or collector should be connected to the positive terminal of the power supply, and E or emitter should be connected to the negative terminal of the power supply, because current always flow from positive to negative. B should be supplied a potential difference in the same direction as C, but with a smaller magnitude. B means base, C means collector. That means when biasing a transistor, higher voltage should be supplied to the collector and lesser voltage should be supplied to the base. Both should be given positive supply. Then the base collector junction becomes reverse biased. Why do I say so? You can remember transistor consists of two PN junctions. One thing, collector and base PN junction. The other one, emitter and base PN junction. So here, when supplying the voltage in the way as I explained earlier, base collector junction becomes reverse biased. Right. Let's study about the circuit of a transistor. Right. Npn transistor. As you can see, this is called as the input circuit. This is how we arrange the circuit, input circuit. All right, children. Now I am going to show you the input circuit of Npn transistor. As you can see, the input circuit, two dry cells are there. Dry cells are connected to the bulb and the transistor. I have given a switch also. This is the input circuit. You can see the structure of the input circuit in the slide. Input circuit. Right. Now I am going to show you the output circuit of the Npn transistor. This is the output circuit of the Npn transistor. You can see the same circuit using the circuit diagram in the slide. Here, two dry cells are connected, bulb, collector, emitter, a switch is there. Right. This is called as output circuit of Npn transistor. Right. Then I am going to light up a bulb using the circuits here. First, I am going to switch on the input circuit. As you can see, when I switch on the input circuit, bulb glows, disconnecting goes off. Right. When I am going to switch on the output circuit, nothing happened. Bulb does not glow. Right. Now, here, as you can see, this is the input circuit of the transistor. This is the output circuit of transistor. Here, before moving to the next part, I am going to ask you some questions to remember the things that you learned so far. Let's remember, there are simple questions. The blank, negative, positive terminal of the cell should be connected to base and collector. What should be the answer? Which terminal should be connected to the base and collector? Positive terminal. The positive terminal should be connected to the base and collector. Question number 2. The blank, negative, positive terminals of the cell should be connected to emitter. What do you think? Negative terminal should be connected to the emitter. Right. Another question is there. The base of the transistor should be given a blank, higher voltage or lower voltage. What do you think? the base of the transistor should be given a lower potential or lower voltage. The collector of the transistor should be given blank, a higher or lower potential. The collector of the transistor should be given a higher potential. Right. Now you can remember basic components. Right. What are the functions of a transistor? Do you know? Why do we use a transistor? My dear children, we use a transistor as a switch because transistor acts as a switch. And also we use a transistor as an amplifier. So transistor acts as a current amplifier. Not only that, transistor acts as a signal amplifier also. Let's focus our attention on the function of a transistor. Right. As you can see, when both the switches are kept open in the input circuit and output circuit, what will happen? Here, bulb does not light up. L1 bulb does not light up. L2 bulb also does not light up because both the switches are kept open here. S1 switch, S2 switch, both are kept open. Bulbs do not light up. Then we only close the S1 switch. When only the S1 switch is kept closed, what happens? L1 bulb lights up, but still S2 switch is kept open, bulb does not light up. L2 bulb does not light up. Now, when only the S2 switch is kept closed, we keep the S1 switch open, we keep the S2 switch closed. Now what happened? Nothing happened. Bulb or L2 bulb does not light up. L1 bulb also does not light up. Now, then we are going to keep both the switches closed. When both the switches are kept closed, what will happen? You can understand both the bulbs are lighting up, L1 and L2, but there is a difference in the brightness. Let's learn about in coming slides. Right. L1 bulb lights up, L2 bulb also lights up. Right. But the brightness is higher than the L1 bulb. The brightness of L2 bulb is higher than the L1 bulb. Right. When turning the switch S1 on and off while the S2 is kept closed, we are going to do another activity. Right. Then what happens? When keeping the S1 switch on, S2 switch closed, in that instance also L2 bulb does not light up, and also L1 bulb also does not light up. Now, when turning the switches S1 on and off while the S2 is kept closed, here when both the switches are kept closed, both the bulbs light up. You can see. What is our conclusion? Before arriving at conclusion, let's do a simple activity to study the things that we learn in practical manner. Right. This is the input circuit. Switch on, L1 bulb, close. This is the output circuit. Switch on, nothing happens. L2 bulb does not light up. This is the circuit made by combining both input circuit as well as output circuit. S1, close up, S2, close up, it doesn't light up. When closing both the switches, you can observe very clearly both the bulbs are glowing. Both the bulbs are glowing. But can you see a difference here? Yes, my dear children, you can see a difference. The brightness of the L2 bulb is higher than the brightness of the L1 bulb. Again, you can see the difference. Right. Then, according to these activities, what is our conclusion? Although the L1 can light up using the power gained by the input circuit, the lighting up of the L2 in the output circuit depends on the current flowing through the input circuit. If there is no flow of current in the input circuit, there is no flow of current in the output circuit. Then we are going to focus our attention on the amplifying process of a transistor. There are two instances. What are they? Current amplifier and signal amplifier. First of all, let's study about current amplifier. As you can see, this is the circuit present in your textbook. When the resistance of the variable resistor is maximum, bulbs do not light up. You can see here, we use a variable resistor. We can use a volume controller as variable resistor. You know, my dear children, variable resistor means a resistor where the resistance can be changed as we need. Right. Before going to the conclusion, let's do the activity. Here, input circuit, output circuit. You can see that when increasing the resistance using the variable resistor, bulb does not glow. When turning that variable resistor, the resistance decreases. When the resistance decreases, flowing of current through the output circuit increases. This is called as amplifying function of transistor or current amplifier. But here you can see the brightness of the L1 bulb is very low. Brightness of the L1 bulb is very low. Brightness of the L2 bulb is very high. That is because of the amount of current flowing through the circuit. Brightness depends on the amount of current. When a low current passes, brightness decreases. When a high current passes, brightness increases. You can see the variations when controlling the variable resistor. Right. Then, what is our conclusion? When a very low current passes through the input circuit, a higher current passes through the output circuit, because the transistor acts as a current amplifier. Right. The input current or the base current is microampere range. We call it's very small amount of current. And the output current or the collector current is 1000 times larger as it is in milliampere range. You have to understand that input current is very low, we call base current. Output current is very high, we call collector current or IC current. It is 1000 times larger than the base current. Right. My dear children, as I told you earlier, transistor acts as not only a current amplifier. Transistor acts as a signal amplifier also. Let's focus our attention. Signal amplifier. when connecting the speaker to the main circuit here, a very low musical sound can be heard. Here we use an integrated circuit called UM66 as mentioned in your textbook, in which a musical tone is included. Right. Then we can hear a very low musical sound through the speaker. Then, when connecting the speaker to the output circuit, as you can see, we can connect the speaker to the output circuit. A higher or an amplified musical sound can be heard. Right. What is the purpose of connecting a 22 kilo ohm resistor? You can see this in your textbook also. As you know that it needs only a very low current, so we have to use 22 kilo ohms of resistor to supply the base voltage for the transistor. This is called as biasing the transistor supplying a base voltage of 0.7 volts. Do you know the reason for that? Because the voltage barrier in the PN junction of silicon diodes is 0.7 volts. Right. In the second circuit, you can see, as mentioned in your textbook, we have to supply a capacitor. 0.1 microfarad capacitor also we have to supply. The capacitor is used to minimize entering of direct current, because we supply microphone to the A and B terminals. Microphone gives AC signals. If direct current enters the circuit and a noise may arise, as a result, we use a 0.1 microfarad of capacitor here. Right. Let's do the activity. Here, when connecting that, a very low sound can be heard. A very low sound can be heard, but it is a very low sound. Now I am going to connect this to the amplifying circuit. Now you can hear a very high sound can be obtained. That is because of the amplifying process of transistor, which is called as signal amplifier. Right. Then let's focus our attention on the switching action of a transistor. As I told you earlier, transistor acts as a current amplifier, signal amplifier, as well as a switch. Right. When the resistance of VR is minimum, in the circuit diagram, you can see VR means variable resistor or volume controller can be used here. When the resistance of VR is very low, current passes through the output circuit from dry cell to the F, F to G, G to A to B, B to C through the variable resistor, because resistance is minimum, from C to D and from D to E, and again from D to F through the dry cell. This takes place when the resistance of the variable resistor is very low or minimum. Right. Now, we are going to increase the resistance of variable resistor until the BE voltage gets 0.7 volts here. Then what happens? When increasing the variable resistance of variable resistor. Right. current passes from dry cell to F, F to G, G to A to B to base through the transistor. Here current does not pass through the C. Current passes towards the transistor as the base current from the transistor to the emitter D, D to E, E to dry cell. Right. When the B voltage gets more than 0.7 volts, what will happen? As you can see that when the B voltage is more than 0.7, why do I say so 0.7 volts? Because the minimum voltage that is needed to overcome the bias in voltage is 0.7 volts. Right. What happens? Current passes from dry cell to F, F to G, G to A to B to transistor through the base, transistor to the emitter, after that D to dry cell towards that here. As a result, what happened? Bulb glows because collector current passes through the bulb. Here a considerable amount of current passes. As I told you earlier, it is milliampere range current, bulb glows. Right. Before arriving at conclusion, let's do the activity. All right. Here variable resistor is there, volume controller. When the resistance is minimum, current passes through the external circuit, no current passes through the voltmeter. You can see that voltmeter reading is 0. When I am going to increase the resistance using the variable resistor, you can see that voltmeter indicator deflects right side, and also bulb glows. Again, bulb does not glow. Voltmeter indicator is also 0 because the resistance in the variable resistor is very low. I am going to increase the resistance of the variable resistor gradually. When increasing, you can see that voltmeter deflects to right side and bulb begins to glow. So that you can understand that when the resistance is very low, transistor acts as an open switch. When the resistance is very high, transistor acts as a closed switch. Anyhow, the voltage indicates that the voltmeter reading as more than 0.7 volts. Right. That means we have to understand that the voltmeter reading between base and collector should be more than 0.7 volts. Then only current passes through the transistor and bulb glows. When the voltage between emitter and the base is 0.7 volts or less than 0.7 volt, current does not pass through the transistor as the current passes through external circuit. That means you can understand, for a transistor to act as a closed switch, the base emitter voltage should be 0.7 or more than 0.7 volts. Similarly, for a transistor to act as an open switch, the base emitter voltage should be less than 0.7 volts. Why do I say so as 0.7 volts? Because, my dear children, 0.7 volt is the minimum voltage essential for bias in a transistor. Let's conclude our activities. What is our conclusion? When the B voltage is 0.0 to 0.7 volt, transistor acts as an open switch. When the BE voltage is above 0.7 volt, transistor acts as a closed switch. Right. Then I am going to focus your attention on the LDR. Function of a LDR with the transistor. Can you remember what is meant by LDR? LDR means the short form of light depending resistors. What does that mean? In LDR, when light falls on the LDR, its resistance varies. When light falls on the LDR, its resistance decreases. When light falls on the LDR, what happens? You can see in this diagram, current passes from dry cell to F, F to G, G to A to B, B to C through the LDR because light falls on that. When light falls, resistance decreases in the LDR. Then C to D, D to E, and through the external circuit. That means when light falls on the LDR, current passes through the external circuit. Right. Current passes through the external circuit, not through the transistor. Current does not flow through the bulb, so the bulb does not glow. Now let's focus our attention. We can cover the LDR. I am going to do this activity. Right. When dark falls on LDR, what happens? Bulb glows. Why is that? Current passes from dry cell to F, F to G, G to A to B through the variable resistor. In that case, what happens? Does current flow through the LDR? What do you think? No. Current does not pass through the LDR because the resistance of LDR is very high. Then current passes through the transistor, through the base, and then emitter to D through the circuit. As a result, IC current or collector current passes, bulb glows. Right. Current passes through the base and transistor, allowing the IC current to flow through the bulb. The bulb glows. We learned that. Before moving to the conclusion, let's do the activity. Right. Now you can see, at first I am going to minimize the resistance, turning extremely left. No resistance. When increasing the resistance gradually, what happens? Current does not pass through the LDR, it passes through the transistor, bulb glows. The variations. When covering that, bulb glows with higher brightness. Light falls on that, current passes through the external circuit. Dark falls on that, bulb glows. The brightness of the bulb can be changed by the variable resistor. Right. Then what is our conclusion? When light falls on the LDR, the bulb does not glow. When dark falls on the LDR, the bulb glows. All right, children. This is the end of our program. Today we studied about transistors. There are two types of transistors as Npn transistor, Pnp transistor. We studied the biasing of transistor, and also you can remember we studied the functions of transistor. It acts as a switch, acts as a signal amplifier, acts as a current amplifier, and also we learn about the function of transistor with the help of LDR. So I think that you enjoyed the lesson. If you have any doubts, please get the support of your teacher and refer to the past paper questions and also refer to the textbooks. If you want, you can watch this same program again through channel NIE YouTube. Have a nice day.